There is one we had talked about yesterday, how summation notation is actually really cool if you're actually going to find the sum, because it's really easy to get all the things that we need for the formula. But the problem becomes, when can we use it and when can't we use it? And we have to know the difference between what an arithmetic sequence looks like and what all the other sequences look like, so we're not using it when we're not supposed to be using it. It's actually pretty easy to tell. And that's because you can only use it for stuff that has n to the first. So that's what this box is saying up here, is that if you want to use that arithmetic series formula, S sub n equals n over 2, a sub 1 plus a sub n, Carl Friedrich Gauss's 8 to 10-year-old formula right there, you have to realize when you check these problems to see if you can use it, you have to see an n to the first power. You have to see that. If you don't, we can't use Carl's formula. That's all about that formula. It is, hey, this is only for arithmetic, only if we're going to be adding the same number every single time. So the box says, if the explicit formula for the nth term in summation notation is a linear function, that means x to the first. Well, we don't use x with these, we use n. So it needs to be n to the first. Then it is arithmetic. Then we can use Carl's formula. So that has to be one of the things that we check right away. It's really tough, by the way, because you look at that and you go, ooh, that's that summation one, and you slap the formula down and you start going like crazy. But you need to pause for a second and say, can I use Carl's formula for this one? And then go forward. So this one says, what is the sum of the series written in summation notation? First thing I do, there it is right there. That's n to the first. I can use Carl's formula. So I grab Carl's formula. And I see where the information is that I need. So I let the formula guide me. The first thing I'd come across is n. I need to know how many. Well, yesterday we said you take 70 minus 1 and then you add 1. Now, if it's 1 down here, you can always just take the top number. But really, we should get used to upper limit minus lower limit plus 1. So 70 minus 1 is 69, but if you add the 1 back on at the end, you get 70. So there's 70 of these. We need the first term. Well, whatever this number is down here, we're going to plug that into the formula. That will give us the first term. So 5 times 1 is 5. 5 plus 3 is 8. That's our first term. I'm going to write that step down. So somebody's looking at the notes later, doesn't go, where'd the 8 come from? Put a 1 in. Now we need the biggest number that's going to plop out of this thing. So what do you suppose we should put into that formula to get the biggest number? 70. Here it is right here. It says the 70th term. So we're going to put 5 times 70 plus 3, which is actually kind of nice to do in your noggin. 350 plus 3, 353. And the rest of it could be totally calculator if you want. Like I said, I usually do a little bit of this math in my noggin because I always mess things up when I punch it into the calculator. So this would be 35 and 361. Quick division and addition in the head. 35 times 361. 12,635, and now we're grateful for the calculator. There it is. So if we were to crank out all the numbers that this would give us, all 70 of them, they would add up to 12,635. They absolutely would. Take a look at me. Here's our pause. First step. Is this really linear? Is it really just going to be an n to the first? If you did the math, n minus 1 times n minus 1, are you going to get n to the first? You can't use Carl's formula. Here's another clue that you can't use Carl's formula. Look at how many terms we're supposed to do. Does it say 1 to 70 again? Only the first 7. That's a clue that don't be using the formula. You just need to stick the numbers in and see what you get. So that's what we're going to do. We're going to start with 1 and we're going to go up to 7 and we're going to add them all together. And a lot of people like to make a little chart for these just to keep things organized. So you don't forget a number as you go through it. So we start with that lower limit, which was 1. 1 minus 1 is 0. 0 squared, 0. Put a 2 in. 2 minus 1 is 1. 1 squared, 1. Put a 3 in. 3 minus 1 is 2. 2 squared is 4. I wouldn't put the 4 in because I've noticed a pattern as I'm thinking through how to get these numbers. What are these numbers? They're the perfect squares. So you could put 4 in, then the 5 in, then the 6 in, and then the 7 in. But remember, every time I'm doing this, I'm saying, okay, this is a number squared. So 4. 3 squared is 9. 4 squared is 16. And 5 squared would be 25. And then our last one here would be 36. So what we have to do is by hand, just add these numbers together. And you could just punch them in your calculator. But what I do is I try to look for groupings that would be nice to work with. For instance, 4 and 16 is 20. Add 20 in my head. 9 and 1 is another 10. There's 30. 25 and 36, that's 61. So I already had 30 from the others. 91. You absolutely could just punch it into the calculator at that point. 0 plus 1 plus 4 plus 9 plus. But the key here is, this is not arithmetic. Can't use Carl's formula. In fact, it's not geometric. If it were geometric, it would look like this. Because that's what all of our geometric formulas look like. Some number raised to the n minus 1. That's what they all look like. That's neither one. It's not going to fit. We have to do it by hand. Now, this one says, what is the sum of each finite series? And there are, what, 3 of them here? So, I want to see your 43210 confidence level on being able to see whether or not you should use arithmetic, and then using the formula when you can, and not using the formula when you can't. So 43210. Yeah, I think if I partner you up, 2 heads are better than 1. So why don't you go ahead and get started on A while I get you a candy partner. At least when I had this, on the farm, yeah, I know. People do it anyway? Yeah. Carrots. Oh, I miss baby carrots when I had this. Oh, baby carrots.
I was dabbling with corn.
Yeah, corn on the cob.
Yeah, that was awful.
You know, my mom would always put it. No races. Okay, where's my pink Tootsie Roll? You know what? Here's the other pink Tootsie Roll. Join any group you want. Okay? All right. Candy up in the air. Find your candy partner or partners. Because Trent's just going to join up with a group of 2 somewhere. Up and out.
Zero out even?
Yeah, I wandered around and generally those that were getting a wrong answer I already talked to about A. And usually it was just a little something like not, that 40, we're gonna have to do something about darkening that up so everybody can see that. But most people by the time I wandered around had the 2,140. For B, it's not an end to the first. We can't use Gauss's formula. We have to crank them out and see what they are. But again, the clue is, oh, they only want us to do from 1 to 4. You know, that means we're not going to do a lot of them. So we can do that. And then you get to this bugger. And the first thing I always hear on this one is, 100? I'm going to do 100 of these? Well, then it should be a clue that there must be something we're supposed to see. Because this is not end to the first and it is not geometric. This doesn't have a little n minus 1 up here, so it's not geometric. So I notice, and Jasmine mentioned this right away. Now this one's got a 0 down there. What are they doing? Well, they're messing with our heads a little bit. That's what they're doing. So you start with a 0 and you say, okay, if n equals 0, what's going to happen here? Well, anything to the 0 power is 1. Let me just put an n up here. And then we put in a 1. Negative 1 to the first is going to be negative 1. But negative 1 to the second is positive 1. And negative 1 to the third, negative 1 times negative 1 times negative 1 is negative 1. Wow. And you notice anything with the even power here is going to give you a positive. So every group of 2 of these is going to cancel themselves out and give you 0 because 1 and negative 1 are 0. So what we really need to know is, do they want us to find an even number of these? Because then the answer is 0. Because every group of 2 is going to cancel out. But do they want an odd number? Because if they want an odd number, then it's going to end up giving us that negative 1 as the first number here. So we have to figure out what's going to happen. Actually, it'll give us the 1 as the first number. So we've got 100 minus 0. But then we have to add 1. And what that means is all of these groupings are going to drop out. There's just going to be that 1 right in the front that's going to be left. So if you write down all 100 of those, 1. That's it. That's it. Add 1. 1. Everything else going to cancel out those groups of 2. So, something like that's not going to be on the test. You know, that's one of those, let's think a little deeper and see the patterns and all that kind of stuff. Now, I had mentioned that we're going to go on a little bit. Actually, I should do this.
No, we're done. So we're.
We're going to go on a little bit into the geometric series today. We're not going to do any homework on the geometric series because I want you to work on Gauss's stuff back there. But we need to get a few of these notes done so we're not like really rushed next week. Geometric series. That means we want to have numbers that are multiplied by something each time. But we want to be able to find what happens when you add them up. Because again, just like before, actually let me grab the highlighter. And we'll come back and highlight this stuff on Monday too. That word series means sum. That's what it means. So we want to know, geometric series, how do you find the sum? And it turns out there's a very nice formula for this too. So geometric series, the sum of the terms of a geometric sequence. There is a difference here. We have 2 formulas for geometric series. We have one for a finite geometric series, which means it stops. If they say, just find the first 10 terms of this series, we have one formula for that. We also have one that says, if the series is infinite, we can find its sum for geometric. And that we'll talk about on Monday. So look at this little monster. Looks kind of scary, but it's just a formula. And the good news is, we don't have to find a lot of things to put in here. We're going to put in n, of course. Oh, my highlighter turned off. Little n right here. We're going to put in the first term, and we're going to put in r. Whoops, that's a 1. Oh, good gravy. Every time I touch anything, I gotta turn the highlighter back on.
What is that pink?
Right
Why
there.
is it?
And we'll do all this highlighting on Monday to remind everybody and those people that are gone what we're doing. Now, the good news is,
It's pink.
they're gonna tell us, hey, we want the first 10 terms. That's it. We're gonna be able to see, or they're gonna tell us a sub 1. We'll have the first term. Or we could just divide and find it. So even though this formula looks more involved, the way that students make mistakes, you punch it in wrong. That's it, you know. I see people that have every number exactly right, and then their answer is messed up because the calculator gave them the wrong answer because they didn't use parentheses for stuff. So this is the formula for a geometric series, a finite geometric series, which means countable. It stops. And so, down here, immediately, no more yakety yak. Here's an example. Use it. Down here, what is the sum of a finite geometric series? And these were the words I was waiting for right there, because that'll tell me which formula I need to use. These are not arithmetic. This is not Carl Gauss. This is us just saying, all right, we got a new one today. Finite geometric series, S sub n equals a sub 1 times 1 minus r to the n, in parentheses, over 1 minus r. So if I can find those numbers, this just becomes a calculator problem. It really does. All right. What is the sum of the finite geometric series? And the first one I see is n. They didn't tell me that. But they did tell me it was geometric. And I have a rule for writing geometric stuff. So I can find it. All right, let's see. I do know the first term. It's a 3. I can figure out r by division. 3, I'm sorry, I'm setting it backwards here. 6 divided by 3 is 2. It's 2. That's what they're multiplying by each time. And what do I want to know? I want to know which n gives me this. So this is what has to go over here. Okay, so how do we get it? Well, we can divide both sides by 3. We'll start there. See what we get. $1,024. But we can't solve that right now because we haven't covered logarithms yet. So what we're going to do is just a little trial and error and try to find a number that we can raise 2 to get 1,024. So it's got to be something big. 2 to the 8th? Nope. 2 to the 9th? Nope, but getting closer. 2 to the 10th. So if 2 to the 10th is 1,024, what number should we put in here so we can get a 10? An 11. Has to be an 11. So n equals 11. Cool. We've got an 11 over here. Do we know the first term? It's 3. Didn't we already figure out what r was when we were over there? What is it? 2. We said n is 11. And on the bottom, just 1 minus 2 again. Now, I never punch that in. Never. This is such a mess. There is so much going on with this. It's just going to be awful. So here's the best thing to do. What's 1 minus 2? -1. What's 3 divided by -1? -3. So I punch in -3 times 1 minus 2 to the 11th. It would be really hard to mess that up. And that will give us our answer. Parentheses and all. Bam-o. 6,141. Should it be big? Yeah, it's geometric. It's going to be big. Going to be big. Let's look at this one. Ooh, nice summation notation. Like that. So, here's what I have to see. This is geometric. See, it's a number times a number raised to a power. But something that throws me off a little bit, it's not n minus 1. Can you see something wrong about the summation notation that would be the reason why it's not n minus 1? They're starting with 0, exactly. So they're trying to mess with us a little bit, but we caught it. So S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Now summation notation is nice because usually we can find what we need really easily. So how many of these, if there's from 0 to 20, how many numbers is that really? 21. 20 minus 0 plus 1, that's 21 numbers. First term, well, we have to put a 0 in to get it. What's anything to the 0 power? 1, so it's really 4 times 1, which is 4. Now r is what's being raised to the power. It doesn't matter if the power is n or if it's n minus 1. So what's r? 1/2. We said we're doing 21 of them. And on the bottom we'll have 1 minus 1/2. I do the same thing with this. I know you guys can do 1 minus 1/2. What's 1 minus 1/2? 1/2. 4 divided by 1/2. Well, you don't divide with fractions. You multiply by the reciprocal. So it'll be 4 over 1 times 2 over 1, which is just 8. That'll be much easier to punch in. Right there. Because it was a mess beforehand. Now, if you're saying, Cedar Home, I don't want to do any math in my head and I'm going to punch this all in, well, let me show you how many sets of parentheses you would need for the calculator to do that right. That's a lot of parentheses. So be very careful. You could do it with all those parentheses, but be very careful. 8 parentheses, 1 minus parentheses, 1 divided by 2 parentheses, to the 21st power parentheses. Bam. Almost 8. Not quite. Almost 8. Notice how I'm still writing that S sub 21 on here, because again, that says I found the sum of the first 21 terms. It's almost 8. Now, just to show you, if you did want to use the calculator for the whole thing, parentheses 4, parentheses 1 minus parentheses 1/2, parentheses to the 21st, parentheses, divided by parentheses 1 minus parentheses 1 divided by 2 parentheses. Whew. It's the same answer, but what a mess, you know? So do a little bit of math in your head. You wouldn't even have to do it in your head, everybody. You could take 4 and divide it by 1 minus 1/2 on your calculator. It'll tell you 8, you know? You wouldn't have to do it in your head. So that's as far as I'm going to go, because I want to keep one of us to talk about, one of these to talk about on Monday, all right? Thank your partner for their wonderful help. And that is the assignment